some point decide you need a calculator to do it. So it's available if you'd like it.
Testing. Okay. 22. Alright, I got this. H of X. Darn. Press the button thing. Equals. I think it's plus X.
Boy, that ghost of room 309 really gets you a lot when you're writing.
Okay, so what are we supposed
Graph
to
it.
do? Graph it.
Alright, so it's asking you specifically if there's a discontinuity when X is 0. And then it gets more specific and says, is it removable or non-removable? We'll talk about that in a second. Okay, you're telling me yes.
Yes, because there's an X on the bottom, and so if X was 0, then it would.
Okay.
It's not possible.
You are exactly right. So there is, in fact, a discontinuity at 0. We cannot graph this function at 0. Go ahead and pull up the calculator and draw the picture, and then we'll talk about what a removable discontinuity is versus a non-removable one.
Alright. It's time to get real.
Putting on our big boy.
Which one is it?
The one, it's not that one, but the one to its left.
Why aren't you moving? Grarg.
More table is required.
Okay.
My mother-in-law, the first time she used a computer mouse, like got to the edge of the table and was like, I had to call my husband and say, what do I do? He was like, pick it up and start over.
Okay. It turned off. Okay, so now I need to see my. Never mind.
Handy dandy notepad.
The function is, go ahead and hit y equals and I'll read it out to you. Alright, clear that.
How do you clear? Can you
Let's
just
see,
write
clear.
over it?
You probably could,
wow.
yeah, but there is a clear button. Alright, open parentheses. X cubed.
Is there an X cubed?
There's an X and then a caret and a.
See, I'm used to my little my little thing that doesn't do anything.
Plus X.
Plus X.
Close parentheses. Divided by X.
I can figure this out.
Hit zoom 6.
And just put 6?
Yes.
Alright.
And that automatically takes you to what's called the standard window, which is negative 10 to 10.
Okay.
Alright, now, looking at that graph, does there appear to be a discontinuity?
There does not from this, like, distance, but.
We're going to look at this two ways. Hit zoom, and do zoom in.
Okay. 2? Alright.
And then hit enter, and it'll zoom in around the origin, which is sufficient for our purposes.
See, you people know this better than I do.
Alright, so we've zoomed in around 0. Still can't really see.
There's kind of a little space.
Kind of a little space.
I sort of see it.
Okay. Hit second.
Yes.
And window. Alright, this is going to allow us to set up a table so that we can see a table of values for this particular function right near 0. So we want to start the table just to the left of 0 and end it. It doesn't matter where we end it. So start that at, let's say, negative 0.1. Okay, and then the table, the delta table is telling you what size increments you want. So set that to 0.01. Okay,
and then
go second graph, and that is going to pull up a table of values for the function that we have entered. Alright, so here's what's going on. Now, scroll down in the table till we get closer to 0. Alright, keep going down, and you should start to see this kind of symmetry on both sides of it. Okay.
Squaring.
So, the table shows us that, yes, the discontinuity is there. Now, is there a way that you could go back to the graph? So just hit the graph button. Is there a way that you could draw that picture without... Is there a way you could define h of 0 so that when you drew the picture you wouldn't have to lift your pencil up? Right now, 0 is not in the domain of h, so we can't draw h of 0. Is there a number we could give it that would allow us to draw the graph without picking it up?
1.
It does look like 1 would work, doesn't it? And even if we go back to, function near 0, yeah, it appears
Oh,
to get closer
error.
and closer to 1, doesn't it? So it looks like if we were to say, can I have the tablet for a second?
Cooper.
Yeah. Totally forgot.
Okay. We're going to redefine H. Have you guys seen piecewise functions? No.
Does not
Okay.
ring a bell.
No.
Alright. This is going to look weird. I'm going to make a huge bracket here. And I'm going to say, alright, H is this thing that we were given as long as X isn't 0. I'm going to say, when X is 0, H becomes 1. Alright, that's called a piecewise defined function because what I've done is I've split the domain of H into pieces, and on each of those pieces I've defined the function slightly differently.
Oh, that worked.
Yes.
So then you could.
Now if I draw this graph, I never have to lift my pencil up.
Could you type that into a calculator?
There is a way, it's kind of complicated.
Yeah, it seemed like it would be really.
But there is a way to do piecewise functions on your calculator, yes. So this function is continuous. We don't pick our pencil up. This, when we are able to do this, this is what's called a removable.
So we
I
can
don't remember if that has
effectively
an E in the middle.
make
Let's
any
check.
graph not discontinuous.
Okay,
Is that a word?
that's a good.
It is. It's. I like that better, but it is pronounced discontinuous. Sorry, I was
Discontinuous.
giving him a. It's my mom's fault. Blame her.
Okay, if you can do this, you have what's called a removable discontinuity. So your question was, is it the case that you can do this all the time? Let's find out. That's not what I want to do. I want to do this.
Wait, I don't think you can.